right, we are on 7.6. We're going to solve a formula for a specified variable. That means I'm going to tell you what variable to solve for, and you're going to be able to do it. You need to know that a formula has more than one variable. Formulas always have tons of variables. For instance, the formula for any parallelogram for area is equal to base times height. I have three variables. I have an A, I have a B, I have an H. Okay, perimeter formula. Perimeter is equal to 2 times the length plus 2 times the width. Formula, three variables. Area of a circle. Area of a circle is pi r squared. 2 variables, an A and an R. Okay, so all you need to know that it is a formula has more than one variable. And when I say solve for a variable, solve means get the variable alone. You want the variable to be by itself. You want it to be like x is equal to something, y is equal to something, or z is equal to something. Some letter equals something. The letter is alone. I want you to reflect for a minute. If I told you to solve this, 2x plus 3 is equal to 7. Raise your hand if you would feel confident solving that. I see the majority of my class would feel confident solving that two-step equation. What would you move first? Just tell me.
3.
And what would you move second?
2.
Okay, if you feel confident with that, you got today's lesson. It just looks more intense. If you know that the first thing you would do with that two-stepper is move that 3, and secondly, you'd move that 2, you are in good standing. Our steps, you move what's not connected. That's the first thing you do. Move what isn't connected. The last thing we do is move what is connected. Now I'm going to do an example. I have a formula over here. A is equal to base times height, and I want to solve it for h. That means that I want h by itself. I know that I need to solve for h because this semicolon right here means solve for. That's what that little thing means. It means solve for. So area is equal to base times height, solve for h. My strategy, I underline what I'm solving for. And then I say, okay, I want to solve for h. Solve means get alone. So I want it to be h is equal to something. And I just start applying inverse operations. What's sticking to the h right now?
B.
And is the b being multiplied or divided or added or subtracted?
Multiplied.
It's being multiplied. B times h. Okay? How do I move multiply?
Divide.
So I'm going to divide this side by b. If I divide the right side, algebra tells me I need to keep the balance and divide it on the left side. Now, I can't do anything with these two, and that's okay. They're just letters. That's all they are. It's just letters. It's okay. Leave them as they are. So I have a over b is equal. The b's canceled out. What do I have left?
H.
H is alone. A lot of us don't like to see it that way, including myself, so I just write h equals a over b. Now I have it exactly like I wanted it. I'm done. How do I know I'm done? Because my h is alone, and that's what I wanted alone. Okay, 2xy equals 3. Solve for x. So my end result, I want it to be x is equal to something. So what's sticking to the x right now?
Y.
And 2, the 2y. Commutative property of multiplication tells me I could rewrite this as 2yx, just so you know, because you're going to see me do something here, and some kids are like, why did you do that? They're being multiplied together. To move multiply, I divide. I just divide everything at one time. So I divide through by 2y. Notice what happens. That cancels out. Oops, I forgot. I got to do it to the right too. And what am I left with on that left-hand side? X equals 3 over, what's on the bottom? 2y. Am I done? Yes, because x is alone. All right. Next example, y equals 3, or no, y plus 3x equals 7, solve for y. So what do I want by itself? So I want it to be y is equal to something. So I underline my y. So I'm going to move what's not connected. That's that 3x plus 3x. How do you move plus 3x? Minus 3x. Now look how I line this up. Minus 3x. I do that for my brain, for my personal preference, because I want to tell my brain they are not like terms. I can't really connect them. I'm just kind of going to put this minus 3x above, because you can't combine them. So I'm left with y is equal to 7 minus 3x. It's not 4x. Am I done? I see some hesitant yes. I want a nice confident yes. I am done because my y is alone. That's my final goal, y alone. Okay, next one. What do I want to get alone on this next one? So I want it to look like x is equal to something. So I underline it. What do you think I should move first? No? Z. Move what's not connected to it. So what's not connected to the x? The z. How do you move plus z? Yep, subtract z. I'm left with 2xy equals 5 minus z. Now again, I want to get my x alone, so now I move what's sticking to it. What's sticking to my x? 2y. How am I going to move it? Divide it. Divide by 2y. If I divide the left side by 2y, then I need to divide the right side by 2y. What's left? Am I done?
Yes.
Because?
X is alone.
Yes. I am done because my variable is by itself. I want you to go through and try to solve the next two. Compare with the student next to you. So, the next one, I see that we had mediocre success. I would say that a lot of us are in between a 2 and a 3. Some of us are very fluent already at a 4. But this is hard. Okay, this is hard stuff. It's very abstract. Anytime you throw more than one variable in there, people are like, what? This is definitely testing your fluency on algebra inverse operations. So this one I am solving for z. So my final goal, I'm going to want z is equal to something. I underline the z. Remember, move what's not connected, then move what is connected. What is not connected to my z right now? 2xy. This is a positive 2xy. How do you move a positive? Yep. So do it to both sides because algebra is all about balance. Yep. Pay attention. So now this is canceled out, right? I'm left with 3z equals, I can't combine them, so I would just write 5 minus 2xy. Now move what is connected. What's sticking to my z right now?
3.
So move the 3, divide everything by that 3. Z is equal to 5 minus 2xy over 3. Done. Okay? Okay. Mhm. Okay, 3a minus 2bc equals 5f. I want to solve for a. So I want a is to equal something. A equals something. Underline it. First, I move what's not connected. What's not connected to my a?
2BC.
How do I move the minus 2bc? Plus 2bc plus 2bc. 3a equals 5f plus 2bc. Divide through by 3. A equals 5f plus 2bc all over 3. I am done because a is alone. Okay, I'm done because a is alone. I'm going to make another one for you to do. You can put your notes away, but get your whiteboard out. Okay, this next example is like your homework, trying to get y alone. Everything you're going to do today is getting y alone on your homework. You want it to be y is equal to something, everything today. So it's a little different formation, but it's the same strategy. Just start moving what's not connected. I know I want y by itself. I'm just going to start moving things over one at a time. It's okay. I get 5y plus 2x equals a negative 3. 0 minus 3 is negative 3. They're like terms. I could combine them. Subtract the 2x over. And I get 5y equals negative 3 minus 2x. That's 5 times y. The inverse of times is to divide. Y equals minus 3 minus 2x all over 5. Done. Okay? Yep. All right, another example. I want you to do one like this. Get y alone. Just like your homework today, it's always y. Get y by itself. Okay, so the first thing I'm going to do here, knowing that y needs to be by itself, I'm going to move my x term, minus 8x. I can combine. I have an x term that I can stick to. So I get 4y is equal to 10 minus 8 is 2x plus 4. Now I'm going to divide by 4, divide all this by 4, okay? So I get y is equal to 2x plus 4 over 4. Now there's a couple ways that you can simplify this. They're all even, aren't they?
Yeah.
So let's divide them all by 2. 1, 2, 2. So I saw a lot of you, I said, hey, that works okay for me. X plus 2 over 2 is a good answer. But an even better answer is to know that I could break this up. This is 2 over 2. You can't just get rid of the 2. It's not x plus 1 or 2x. Some of you thought you could get rid of the 4 right here and say 2x. No. This 4 is also connected to the 2. So what really happens is you get x over 2, which is a half of x, plus 2 over 2, which is 1. That is the best of the best way to do it. However, I will take non-simplified forms because we're just learning, and I will take partly simplified forms because we're just learning. Make sense?
Yes.
All right.
So you would
We're
take
done.
2x plus 4 divided by 4.
Mhm.